All right, so now we're going to talk about exponential decay. So let's take a look at the patterns that we see in these two tables. For the first one, the next number is going to be, well, it looks like we're going up, let's see, 7.5 here, 7.5 here, 7.5 here, so we're probably going to go up another 7.5. Okay, and then for this one, what I want to do is we're going to represent this as an equation. Okay, so what we can do is we start at 2.5, okay, and then we're going to add 7.5 times x. Okay, and so when this is 25, okay, we can go ahead and write that as 25 times 7.5. Okay, we're going to get that answer, and then we're going to add 2.5 to it. Okay, so let's go ahead and do that. We have 25 times 7.5. Okay, and then we're going to add 2.5. Okay, and we're going to get 190 here. Okay, so for the next table, it looks like we're going, this is not linear, this is going to be exponential. And so what we can do is, it looks like, so the x, okay, and we're going to be raising this to a power. Okay, so x is going to be our power. All right, and so what we have is 2.5. Okay, that's where we're starting. And then we're going to have times, to get to from 2.5 to 10, we're going to multiply by 4. Okay, and so when we have, remember, 2.5 times 4 to the 0, okay, remember that is just 2.5 times 1. Okay, and so that's going to give us our 2.5. Okay, and then so what we can do is we can write this as an equation as 2.5 times 4 to the x. Okay, so our x, right, is going to be our exponent. And so this right here, we'll put 640. Okay, and then this one right here, I'm just going to have you write down the equation there. You can figure it out if you want to. All right, so the next one is the algae bloom. In order to control an algae bloom in a lake, scientists introduce some treatment products. Once the treatment begins, the area covered by algae, okay, which is A in square yards, is given by the equation A equals 240 times 1/3 to the t. Time t is measured in weeks. Okay, in the equation, what does 240 tell us about the algae? And then what does the 1/3 tell us? Okay, so remember from a previous lesson that this number right here, okay, is going to tell us what algae originally covers. Okay, so it looks like it's 240 yards. Okay, and then the 1/3, okay, is going to tell us that every week the area covered is 1/3 of the area covered the previous week. Okay. Next, we're going to create a graph to represent our equation. And then it says, think carefully about how you choose the scale for the axes. If you get stuck, consider creating a table of values. Okay, so let's go ahead. I'm going to go ahead and put that down for you. Okay, so I went ahead and put the table in here for you. So you can go ahead and copy that down. And then it says to think carefully about the scale. And so over here, let's see if I can do this. We're going to have our area. Okay, and that's going to be in square yards. Okay, and then we can go up by 25. Okay, and it looks like 240 is our top. Okay, and then on the bottom, our time is in weeks. Okay, and we're going to 4. Okay, and so we can have 1, 2, 3, 4. Okay, we can call this 2. 1, 2, 3, 4. We can call this 4. And we can call that 6. Okay, you might have some different values, but that's okay. Okay, and so at 240, at 0 weeks, okay, we know that we're at 240. Okay, and that's going to be about there. Okay, and then when we go down to 1 week, okay, which is here, we're going to be at about 80. Okay, and so that's going to be about here. And then for the next one, 2, we're going to be at 27. Okay, so that's going to be about here. And then at 3, we're at about 9. Okay, which is about here. 4, we're at 3, about here. Okay, and so when we draw our line, sorry, this isn't going to be the prettiest. Okay, we're going to have something that looks like that. Okay, now about how many square yards will the algae cover after 2.5 weeks? Okay, so what we can do for this one, go ahead and change this back, is we could say that the algae will cover fewer than 27 square yards and more than 9. Because the area covered is decreasing. So we could say that a number between 15 and 20 would be a good guess. Okay, the scientists estimate that to keep the algae bloom from spreading after the treatment concludes, they will need to get the area covered under 1 square foot. How many weeks should they run the treatment in order to achieve this? Okay, so for this one, there are 9 square feet in every square yard. So 1 square foot is 1/9 square yard. Or about 0.111 square yards. Okay, and the reason we're going to foot is we have that in our question. That's what they're looking for. Okay, or that's what they're given. All right, so let's take a look. At 7 weeks, this is the first time the area covered is less than 1/9 because, and we're going to look at our formula, 240 times 1/3 to the 6th is approximately 0.329. Okay, and 240 times 1/3 to the 7th is approximately 0.110. Okay, and so we can see, right, that this is the first time that it went below that. Okay, so the answer is 7 weeks. Okay, insulin in the body. All right, so insulin is a hormone that is needed to produce glucose, which is sugar in the body. For people with diabetes, a disorder in which the body cannot process glucose properly or does not produce enough insulin, injections of insulin are sometimes needed. Once in the bloodstream, insulin breaks down fairly rapidly, so additional injections are needed over the course of a day to control a person's glucose. Okay, and so we have this graph, okay? A patient who is diabetic receives 100 micrograms of insulin. Okay, so we can see that right here. Okay, the graph shows the amount of insulin in micrograms remaining in the bloodstream over time in minutes. Okay, and so we can see that here is 0 minutes, and then over time, okay, it is going to, the amount of insulin is going to decrease. Okay, so let's take a look at this. Okay, so this can be something that you just copy down. So it says, if the insulin decays exponentially, that means that after each minute, the same fraction of insulin will decay and remain. So one way to check if this prediction matches the data is to see what fraction of the insulin decays or remains after the first minute, then after the second minute, and so on. If these fractions are the same, then the graph supports the scientist's claims. Okay, so that's kind of like why it would be exponential. All right, for number 2, how much insulin broke down in the first minute? What fraction of the original is left after that? Okay, so what we can do is we can look at our y values up here, okay? So at 0 minutes, there's 100 micrograms of insulin. Okay, after the first minute, okay, which if we look down here, those are minutes. After the first minute, it has gone down to 90 micrograms. Okay, and so this is going to be 10 micrograms. Okay, broke down. And this is 1/10 of the initial injection. That should be a 1. Okay, so for the next one, okay, we have 90. All right, so it looks like we go from, 100, we go from 90 to 81. Okay, so that's going to be 9 micrograms. Okay, broke down. And again, this is 1/10 of the amount. A minute earlier. Okay, so what fraction of the insulin remains in the bloodstream for each minute that passes? Okay, so we can see here that since, let's see, because it's broken down, okay, 1/10 is broken down. What is remaining is 9/10. Okay, so in the next minute, another 1/10 of insulin broke down. Okay, and then each minute, 9/10, 9/10 of the amount remains. Okay, sorry that's so messy. All right, so the next question. Complete the table to show the predicted amount of insulin 4 and 5 minutes after the injection. Okay, and so what we're going to do is we're going to put 65.61 and 59.05. Okay, and so this is what is left. Okay, that's the amount of insulin that is left. All right, so see if you can get how I get that. Okay, now for the next one, describe how you would find how many micrograms of insulin remain in the bloodstream after 10 minutes and then after m minutes. Okay, so what we're going to do, remember, we have how much we have at the beginning, which is 100. Okay, and then we're going to multiply it by 9/10, okay, which is what is left after a minute. Okay, so after 10 minutes, we're going to put 10. Okay, and then for m minutes, we're going to have 100, okay, times 9/10, and then that's going to be to the m minutes. Okay, and then, as always, make sure you read through the summary.